In this video, I'll be representing the complex number z equals -2 -3i on the Argand diagram. Look at this very carefully and know how to derive the modulus and the argument. So let's see what we have today. Now, since the complex number has already been given, there's no need for us to do any calculation. We already have it here. So we need to draw this on the diagram. So draw this on the Cartesian plane, which is also known as the Argand diagram. So you can start drawing. Let me draw mine. So this is my imaginary line. This is the real line. These sides are positive, positive, negative, negative. So now we have -2. So on the real axis, we have the real value to be -2. So let's assume this side is -2. So let's assume this side is -2. And let's assume this side is also -3i. -3. Now we need to join this side and this side with a broken line. So let me do mine. And we join this one with a broken line. So the point that they meet is here. So this is where we substitute z. The point P is z P into what? -2, -3. So that is what we have. Now we join the point to the center to draw our modulus. So from here, this is the magnitude what? Z, which is the same as R. Now the angle that we form here, let's name this one theta. And the distance from 0 to this side is -2. So I'll put it here, -2, which is what we have here. So the distance from 0 to this side was -3. So let's put it here, -3. Alright, so now we can find the value of theta, but that is not the angle that we are actually looking for. The actual angle will be read from this side until we get here. So I will work on that. Now let's calculate for theta and then calculate for r. Now theta is facing here. This is opposite over adjacent. So tan theta equals opposite over what? Adjacent. So we have tan theta equals opposite is 3, which is 3 over adjacent is what? 2. Don't use the value -2. There is no need. We don't do that. So for us to get theta, we take tan inverse of 3 over 2. Theta equals tan inverse of what? 3 over 2. So when you take tan inverse of this, the result is 56.309. Let's assume it is 56. So theta equals 56 degrees. Now come back to the diagram. Let's find out if theta is the actual angle we want. Since theta is below the real axis, we are taking the reading in the clockwise direction, starting from 0 until we get to -180, because every angle here is negative. So from 0 to negative, but we are moving in this direction. So we are moving from here up to here. So the angle that we are looking for is from here up to this side, not theta. But since we have the value of theta, when we subtract from 180, we can get the angle, which is the actual angle, known as the argument. So we are looking for the distance from here up to here. And let's name that side alpha. Now we have access to theta. Alpha plus theta should be equal to 180 degrees, because the whole distance will be 180. So we have, therefore, theta plus alpha should give us 180 degrees. But we are looking for alpha, so alpha will be equal to 180 degrees minus the angle theta. We have alpha equal to 180 degrees minus 56 degrees. Now remember that alpha was below the real axis, so the value of alpha should be negative. And to be able to make the value of alpha negative, we just have to negate what we have here. So we have alpha equals negative outside 180 degrees minus 56 degrees. Now when you subtract this, we have alpha equals -124 degrees. Now we can find the modulus, which is the magnitude of what? R. And to do that, you know the magnitude of z, which is the same as r, to be equal to the root of a squared plus b squared. And we know a to be what? -2, b to be what? -3. There's no need for you to bring the negative if you want to. So we can have -2 all squared plus -3 all squared. So we have the magnitude will be equal to root of 4 plus 9. So we have r equal to root of 13. So now our modulus r, or magnitude r, equals root of 13. So we are supposed to leave the results in the polar form. So in the polar form, we have complex number z equals r into cos. Now the actual angle we found was alpha, not theta. So cos alpha plus I sine alpha. So we can substitute the value of r is root of 13 into cos alpha gave us negative 124. So minus 124 degrees plus I sine minus 124.